So this video is going to be on parasitic drain, and the purpose of this video is a parasitic drain. What it is it is an unwanted drain on the battery. So in other words, you bring your car in at night and park it. The next day you go out to get in your vehicle and the battery's dead. So something is staying on when not turning off when it's supposed to, and it drains the battery overnight. And so the purpose of this video is to show you how to identify whether or not you have a parasitic drain and how to diagnose it. So let's go ahead and get started. One of the ways that you can test to see if there is a parasitic drain on the battery is by using this parasitic drain tool. And what this is a switch that we can install on the battery that opens and closes the main circuit of the battery. So by twisting this knob here, it's like disconnecting or connecting up the battery. And that's what this is a tool we're going to be using. Another name for this tool is a battery isolator. You can purchase these things at RV shops because a lot of times people use these to charge their RV batteries as they're going down the road. They can turn this so that it is connected, and then as you're driving down the road, your alternator keeps the RV battery charged. And then when you park and you want to use your RV battery, you open this up, you turn the knob this way, counterclockwise, and it opens it up, and you don't drain the battery in your car. You only drain the battery on the RV. So that's where these come from. You can buy these on Amazon. You can get them at the local parts store or wherever. But anyway, that's what this is, a battery isolator. And the way it works is, like I said, it is connected when the knob is switched or turned all the way to the right or clockwise. And what it does is it connects up these two pieces. So you have a piece here and a piece here, and they're actually separated by a plastic insulator. And you can kind of see that plastic insulator here. So they're separated by that. And when you turn the knob all the way to or counterclockwise, basically what happens is it separates those, and then when you turn it all the way clockwise till it stops, now you've connected them. And to prove this, what we'll do is we'll look at it with an ohm meter. So if I was to put my meter leads on this tool just like so, if you notice I've got 0.2 ohms of resistance, and if I open it up, I turn that knob, we have open circuit, or OL, out of limits is what that means, is OL. And then if I turn that knob again, there we go. It's connected back up again. So that's how this tool works. And if you're working on a battery with side post terminals that we talked about in the last time, you will need these adapters that we used for load testing the battery. If your battery already has these terminals on it, so in other words it's a top post battery, you do not need to use these adapters. So the battery that we're going to be testing here is actually a side post, and so I'm going to go ahead and install these two adapters, and I'm going to install the switch, and then I'll come back and we'll go ahead and do the diagnosis. Okay, here's a close-up of how I've got the battery isolator hooked up. So you can see I've got it screwed into the battery post down here. I used one of those lead adapters that goes into the battery post so I could clamp around it. And then up here on the top, there's a hole in this one. And so I just ran a bolt straight through the hole into the battery cable. So it connected the battery up that way. So now I'm going to back the camera off a little bit so you can see how I'm going to hook up the meter, and then we'll go ahead and check it for a parasitic draw. Okay, I've got my meter hooked up, and what I've got is I've got the negative cable of my meter hooked up to one side of my battery isolator, and my positive meter lead hooked up to the other side of the battery isolator. And I'll kind of zoom in on that so you can kind of see a little better how that's hooked up. Okay, And then with my meter, just as a reminder, because you guys should already know this, I've got it set on amperage, and I've got my meter lead set on amps and comm. Now the reason I have it set on amps, because if you remember from the chapter, if you've gone through the chapter, you'll know that you should see no more than 50 milliamps as far as normal amperage draw on the battery is. So you should see no more than 50 milliamps. And I don't know how much I'm going to see, because if I have a draw on there, I might see 2 or 3 amps. I don't want to put it in the milliamp scale, because the milliamp scale is only a 3 amp fuse, and if you put it in there, you may end up blowing the fuse in your meter. So I always start with the amperage scale and see where I'm at. So let's go ahead and open it up. So I'm going to open up the knob here. So I'm going to turn it counterclockwise. And this is my parasitic draw right now. So you see the numbers change there. I'm drawing 1.042 amps. So like I said, half an amp is normal. I mean, that's maximum. You shouldn't have more than half an amp. Now what's happening now is, because I just disconnected the battery, I've got something drawing some amperage. Now if you notice, I've got a hood light on, right? That hood light's going to draw some amperage. So I need to turn that hood light off. And so I'm going to unplug it. There we go. Now as soon as I unplugged it, you may have seen the amperage drop down to 0.030. So that's 30 milliamps. That's pretty normal for most parasitic draws. So if you were to have more than 50 milliamps draw on the system, the way you would find that is you would go to the fuse box and you would start plucking fuses out one at a time until the amperage goes away. And then once the amperage goes away, then you found your circuit that the amperage draws on. So if you notice, when I connect this back up, I get it wrong. So if I connect it back up, I should see 0 amps, because my meter leads right down here are not in parallel with anything. They're actually in series. And so basically all I'm doing is putting my meter leads across a wire. There's no resistance, or there's no load that I'm measuring there. So there again, so if I open this up, that's my parasitic draw. And when I close it down, my battery died on that last one, so I had to switch cameras. So anyway, that was the parasitic draw test using a amp meter. There is another way to test amperage draw on the battery, and that's using one of these amp clamps. And so I'm going to show you how to do that now. This is actually a much easier way to test for amperage draw, because you don't have to disconnect anything, you don't have to connect anything up. Now, having said that, this is easier, but the method that I just showed you with the DVOM is much more accurate. This one is not quite as accurate, because sometimes it'll pick up different interferences and stuff. And I'll show you that kind of as we move along. Now, the way this tool works, well, I'll show you how it works, and then we'll do the test. Okay, with this tool, what we're going to do is we're going to, this is your selector switch, and so what we're going to do is we're going to set it to DC amps, and it'll come on, it'll start scrolling through some numbers here. On the side of it, there's a peak and hold, and that's also the 0 button. So 0 it out, so just push it and hold it, and you see the numbers zeroed out. And now you're ready to go. And so let's go over to the vehicle, and all you need to do to test on this one is to clamp over the wire. Now if you see, there's 2 positive terminal battery wires on here, and I clipped over this one, and it says 0.05 or 0.04. It's kind of bouncing around there, which is that's totally acceptable. Now if I clip it over to the other ones, nothing changed. So now I've clipped it over both of them together, and we're at about 0.7. So 7 millivolts, or milliamps, I'm sorry. So 7 milliamps, bouncing between 6.8, 7. Now, that's a little bit higher than we read on the DVOM. And that's kind of what I was talking about when I said that this method isn't quite as accurate, because it does pick up other things sometimes. Now I'm going to keep this camera, or this reading right here is 0.4, bouncing between 0.46 and 0.48. So that's basically what we were reading with the DVOM. But that's using an amp clamp for doing a parasitic draw test.